All right, this is a discussion about some of the problems that you might have in the field, about loss of grid drive, poor grid drive. One of the things that can cause that, of course, is the malfunctioning multiplier. Here's a multiplier section. And as we mentioned earlier, we have some tuned circuits here. This is the capacitors taken out of one that had loss of grid drive on two of the positions, complete loss of grid drive. The first multiplier section here goes up to about 8 megahertz, from 2 to 8 megahertz. And actually that's a C111. This is a C111 pulled apart. The C115 is the secondary over here. And turns out that this particular unit came out of Florida, had a very harsh environment. You can see some of the tarnishing that you have on some of the components here. Two capacitors were completely open. And what caused that? Well, we have good people at Rockwell Collins in Advanced Technology. Brian McCoy, who's a ham, is helping me in this. Here's one of the two capacitors. I'm going to spread this out here a little bit so you can see a full view of what's going on. You got good view on that? All right. Consists of two plates, basically. Here's a plate on the movable portion. Here's a plate on the fixed portion. This is one of the lower value capacitors. By the way, there's actually 5 different capacitors in this thing. The one on the lower frequency has a range of something like 425 to 430 or something like that. It's a very high range capacitor. This is one on the smaller end. The one on the opposite end goes from something like 18 to 35. Now, what happened with this? This is an open capacitor. There's two places where it can cause problems. You have a press ring. You got to remember that everything on these capacitors is just a press fit till you get to the wire. They're on a column that has a shaft that goes completely through the center of each one of them. And actually, that's the B plus side, the low voltage side. And then the other side of the capacitor is the little tab that comes out on the other thick plate. You notice that there's a rivet right here on the tab. If I turn that over, the back side is epoxy. You look at any one of these capacitors. This is one that hasn't been touched. There's an epoxy back here that holds that lug into place. If that lug is wiggled and moved, it turns out that we should have recognized this because the lug was wobbly on the two capacitors that were bad. And what was happening is there was no conductivity between the plate and the solder tab. Completely open. There's a rivet that goes through there, and I think that each one of these has some sort of a epoxy that's got a conductivity. Brian used a silver epoxy to epoxy that back to the plate, and that works. And then he actually used a different type of epoxy to re-epoxy this. It's important that you don't move those tabs on these things because you can open them up. The other area of problem is you notice that the movable port has a plate here. This plate is silvered right up into the notch on the ceramic in two places. The larger ones that have all the way around, it's like this one is silvered right up into the... So the contact of the movable plate is through this spider here that has 3 prongs on it. And if you look at the tarnish in some of these things, that is also a root cause of problem. If you get into a situation where the back side of this thing, and that silver, turns black, and by the way, most of these were black when we took them out of the unit. that could cause a loss of conductivity between where this meets the plate. The other problem in these, if you look at some of the structures of these, all of that, is that conductive or not? Is that conductive or not? Could it be resistive? Could this be dragging down your tank? A tank circuit's got a high circulating current at resonance. Any resistance in that can cause the Q of the tank circuit to go to pot. And you might have low grid drive because of that. So this is probably a common problem with the multiplier section. Other than you could have leaky capacitors, you know, from plate to grid, that could cause problems. But this is clearly a problem that we have with this unit, where we had 2 channels at 2 frequencies. Actually, there's 4 frequencies, because what's happened on this is on the low frequency side. So when you get to the tripler, on anything above channel position 6, 7 through 12, it affects that as well. That's something else to consider. If you see something affected on one of the higher ones, you better check the counterpart on the lower ones, like 2 and 7, 1 and 7, 2 and 8, etc., etc. So that's very important. Basically, that's
quite an overhaul project.
Is that it?
Oh yeah. Here is one of the units. You notice this black around the hardware is silver plated, all black. And most of these things were black. They've already been pre-cleaned, and I'm not satisfied with the way they are. I did locate a deoxidizer and cleaner. It's a commercial product found in the food store, and I'm beginning to work with that. What we got to do is get in here and just clean all that metal up. It may take several passes, but as long as you got brass in a case like this, or metal, fine, because the conductivity is through the center thing, and you got stacks, you got one against the other, you got this with a collar against it and so forth, and that's your total conductivity for this, for the B plus side of the thing. So you got problems there. You might have loss of grid drive due to high resistance in your plate current. So basically, it's just a matter of getting something that would deoxidize silver. Anything that would treat and get rid of the oxidation on silver is what you need to do. If you ever take one of these things apart, make sure that everything is bonded and everything is clean before you put it back. And when you solder the leads, the original has a loop right through each one of the lugs. It's best to treat that very gingerly, and even if you have to cut off some of the wire and just poke it through the hole and solder it. That's what we're going to do with this one. We just poke it through the hole without wrapping it around. As long as it's a good solder connection, that's all. But don't touch those leads. Don't wiggle them. That's it.
Okay, you know, I wanted to thank you, but before I do that, I'm going to pass along to our viewers one more little warning that you wanted to pass on. There's a choke right here that's the grid return on the final, and it is dangerously close to the cover. It's okay with the cover on, but with the cover off, if you're working on a workbench, do not get anything that's got any height into that choker. You're going to lose the choke. So that was the last little hint that Jules passed on. And with that, I want to say, Jules, for all of us, thank you so much. It's been a pleasure working with you and a pleasure meeting you, and I hope that the meeting you part hasn't ended.
It's great. I'm still learning.
Well, I have to say that I started out intimidated by this box, and you've given me enough confidence to forge ahead. So I'm no longer intimidated. I'm going to be cautious, but not intimidated. So thanks
maybe
again.
someday you'll hear me on the air with an ART-13. I've actually got one in the garage here, but I haven't had a chance to do anything with it.
What's your call sign?
KW0Y.
Well, we will look for KW0Y on the air, and
AM.
nothing would give me more pleasure than to work you ART 13 to ART 13. That
Well,
would be fun.
I want to work Fifi. That's ART 13 to ART 13.
Yep.
That's great.
Okay, well listen, thank you again.
My pleasure. You take care.